All right, so let's just dive into this. So we'll have a look at the description of the sessions, or actually, let's have a look at the course progress first of all. So I made this kind of Gantt-like thing for you, just so it'd be a little bit more clear. Why is it all in that little? Oh, I can do it like that. Okay. This is a new system we're all getting used to. So here you go. So this course runs up until Christmas. Your final delivery is December 6th. Um, Seems like people are still struggling to get in here. Yeah. So first session today, we're going to get an introduction to Maya. We're also going to have a look at some like brief history of CG art, just so that you're familiar with some of the key figures and things that you should know. Basically. Next session will already be next week, so we're going to do polygonal modeling. Obviously, we're going to get started with that a little bit today, but then mostly next session. Um, okay, next session after that, we'll do polygonal subdividing. So it's basically taking those simple polygonal meshes and then turning them into more smooth and nice meshes by using subdividing. So then basically looking at how you can control the curvature of an object using creasing edges. So the placement of all the edges will define the curvature in your final model. And then we have this session devoted to troubleshooting. So basically looking at all the problems that will definitely arise. And then we'll just devote this entire session to dealing with a lot of issues and troubles. So for this session, I encourage you, if you have some problems you'd like for us to address, you could give me your mesh or just tell me, hey, Julian, could you cover this in class? And I'll be happy to use your model as an example and try to figure out what went wrong. So it's such an integral part of modeling. There's always some issues and problems that we have to attend to. So it's very rarely that everything works out just A, B, C, D, and then you move on along this perfect trajectory. It's very rare. Okay, and then session 5, UV mapping, basically understanding UVs and how that works. And we'll do a simple color map, just very simple, going from Photoshop to Maya, kind of old school. Session 6, we're going to use another program called Hedus UV. So Maya also now has some pretty good UV tools. I still prefer Hedus because it has a very good unwrapping algorithm. So it's up to you if you want to use it or not, but we're going to cover that. And we'll cover some other maps, kind of like in the traditional texturing approach. So spec map, bump map, all kind of the old school maps. Those are not mandatory for the course. In other words, you don't have to do them. You can just do a very simple color map. And that's it. So as far as the deliveries, the first delivery is obviously next week. It's a primitive city. You're going to try to construct a city in Maya using polygonal primitives and just adjusting the components like vertices. And I'll basically be showing you that today a little bit. But then we'll get together on Monday. Oh, yeah. So it will be Monday from 4 till 6:30 for you guys, since you are the ones who are here. And then the games will be from 6:30 till 9. Still no one from games here right now. So they have something else going on. Okay. But anyway, so this Monday will it'll sort of be the first lab session. Not today because you're going away. So I hear. I don't know. So that will be with the TA in the course, who's Luai, who's the teaching assistant, and he will be with us on Monday. So you do the primitive city, and all the hand-ins are just PDFs. So you do a little reflection. You can write like a paragraph or something about whatever you did. But the main thing is that you include pictures. If you can, include iterative pictures so you show the progress. Not so important for this first one, but for the later ones, it'd be very nice if you can make it a habit to save often the Miocene so that you can actually go back in time for the purposes of the report and so that you can document the progress a little bit. So yeah, basically you'll be doing a kitchen. So we're doing kitchen furniture, kitchen props, and UV mapping them and texturing them. So yes, there is no requirement for like a minimum amount of papers. The absolute requirement is that they include images. So you have to document the work. It's the only hand-in you'll do. So the more you can sort of, okay, so that brings us over to what's required and so forth, and the kind of assessment. And that's actually, if you're bored one day and you can go in here and have a look at the assessment brief. It's basically everything's in here. So this is also what is given to, let's say you, well, anyone who's involved with the assessment. So initially that's me and another internal, but then if you contest the grade, you want a better grade, that this will go out to the external censor. So this is kind of the important document. So this is the assessment brief. So there's all this, you can read through it. I'm just gonna, it's basically all the assignments. They're also in here, but at the bottom, yeah, so this is kind of a boring topic, but we can also get back to it. But if you're curious how the assessment will work, these are elements of assessment. So there's the reflection paper. You can see it only counts like 20% of the weighting for the A1, and then the modeling and all of that counts 80%. It says UV there. There's no UVs in A1, so I'll update that. But anyways, so you'll see there's slight different weighting. So here there's a reflection paper 20%, modeling 60%, texturing 20%. So the texturing only ever counts like 20% of the weighting of the final grade. So the most important thing is the modeling and the UVs. And there's an optional one, A5. This is, you can just make any hard surface acid. It's optional, you can do it. It will be nice for your grade if you choose to do it. And also for that, the texturing only counts like 20%. In addition to that, there's like a weighting per assignment, so that this is all kind of designed so to benefit you, because the later assignments will have more importance in the final evaluation, so that you can actually have a progress in the course and still achieve a good grade. And this, I do this, so I actually do 3 calculations based on all this, and so there's a straight average. You don't have to worry about all this, it's just in case you're interested. There's a straight average, and there's a weighted average, and there's a weighted average with the optional one. Whichever one of those are more beneficial for you, that will be the basis for the letter grade. And for the letter grade, you refer to this assessment rubric. So if you're really interested and you want to look at what goes into the assessment per element, go here. See, okay, for an A, you need that, and so forth. Okay, so this is just to be on the same page with all the people involved in the assessment. So that's how that works. So you can read that on your own. I'm not going to spend time with that. But it's all in here. Okay. So for the description of the sessions, session 1, we're here. We're going to look at a brief history, like I said, of CG art, and very short introduction to Maya today. And yeah, so you can also go in here and have a look if you want. So I think it should be pretty clear. Do you have any questions about the progress or assessment? It's doable. No. Okay. So that's that. Oh, yeah. And here are the assignments. This is where you hand in the PDFs. Should be good. No, it's making noises again. All right, so that was pretty clear. You don't have any doubts about the progress? Nope. So obviously, those sessions, that's when I'm here, and I'll be with you on the lab sessions for that week whenever I'm here. The other weeks, sometimes you'll be on your own. Sometimes you'll have Luai with you, who's the TA. But there's also other TAs that will be here Mondays, I think. There will be like food servings on Mondays. I don't know. They were talking about this. Sounds nice. See if I can get this working. All right, so let's just get started with today. I'm just going to close here. So, all right, so CG art. Seems like most of you are not completely new to CG, but some of you might be. So CGI, usually computer generated imagery. You skip the I, CG could be computer generated. So anything that's referring to something that's processed computationally using 3D. So CG art being one of those, so you skip the I. Sometimes CG also just refers to computer graphics. So what has CG been beneficial for, in your opinion? Like, what has it brought us? Yeah. What's that? Yeah. Okay. Fictional content. In what sense? Yeah. Cartoons come to life, or like a heightened realism and illusion, perhaps. Kind of, you know, you can basically do anything you want, but I think that's one of the main. I agree. That's kind of one of the main things that you can do. Whoa, crap. You can do conceptual things to a heightened degree of realism. This is hardly a new kind of goal. So if you look back to Alberti, I don't know if anyone knows him. He's probably one of the earliest art critics. So he wrote a book in 1435 on painting, pre-Renaissance era. So a painted image is an open window through which we look at the world. So this was sort of the ideal, especially in the Renaissance, starting in Italy. So if we take a look at a very early painting, this is Giotto. Giotto was obviously, one of the masters, early Renaissance or pre-Renaissance master. You can see that there's already some present here of, we do have some perspective, a little bit. But it's still quite crude, the characters are kind of flat. But it's been this gradual implementing of perspective, which is kind of taken to another level a few years later. So this is Raphael's The School of Athens, which is in the Vatican. So this is, at the height of the Renaissance. So literally at the same time you had Michelangelo next door working on the Sistine Chapel while Raphael was painting this. So you can imagine how, did he just show up one day, all right, and get his pencils out and, let me see what I can do? No, of course not. This is a highly engineered picture. It's very, very intricate. You can see there's very, the calculations made of these receding geometrical elements. It's kind of like a tour de force of really kind of mastering perspective. Also light, like light bounce, shadow and light, but mostly the perspective here is kind of what brought this to a new level of illusion. And if we take a look at the perspective lines, so you just follow every single line and they'll all converge exactly in the middle, at this middle vanishing point. So This is a single point perspective. When you take art classes, you can be experimenting with 2-point, 3-point, or several points of perspective so that you can skew objects accordingly. I guess you'll all be doing that in the art classes you take here also. But obviously, it's a very engineered image. It's not an accident. And this is sort of the main things that came about with the Renaissance, the implementation of perspective. And then we move on to Holland. So Dutch Golden Age painting is often associated with a heightened realism, but in some ways it was kind of illusionism, in which the painter's knowledge of how nature looks to us was deployed to fool the eye in various ways. This is Laura J. Snyder. She has an interesting book called Eye of the Beholder. So this is talking about Dutch Golden Age painting in the 1600s, late 1600s. So are you familiar with Vermeer, Johannes Vermeer? So I mean, this again is like taken to a new level, I think, in terms of heightened realism and illusion. So we can draw very intricate perspective lines, and we can see that they're all matched up. And this would be an example of a multiple perspective vanishing points. We'll have one vanishing point over here. Well, we could do that. But I think the biggest change here is not the perspective, but rather the use of light. Is the incredible attention to detail, but also the light is just remarkable. So that has led a lot of people, a lot of art historians and critics to the conclusion that Vermeer must have made use of quite extensive use of optics. So camera obscura techniques, but also taking that to a new level. So are you familiar with this? This is also a Vermeer's the music lesson. It's the Queen of England has it in her private collection. One of those is a copy. I don't know. You can probably spot which. Which is the copy? Yeah, the one on the left. It's pretty obvious the lack of, that painting is a bit older. And the other one is like 5 years old. But it's a very interesting example. This is actually a 3D guy. He's kind of a CG guy called Tim Jennison, who's an inventor, who decided to do this as a project. And there's a movie called Tim's Vermeer, where he basically is a documentary that shows this process. It's very interesting, and I think we'll get around to watching that at some point. But he makes some very simple or actually takes it a little bit further, the camera obscura techniques, to the point where he can actually sit in an open space. He doesn't have to be enclosed within a dark room. So he can sit out in the open and paint. And so he grinds his own lenses, and he does everything according to the way Vermeer, all the techniques he would have had access to in Delft at the time. So yeah, very interesting movie and a pretty remarkable result. So he was inspired by a book by Philip Stedman, I think, called Vermeer's Camera. So he actually does like very precise geometric calculations, showing that maybe Vermeer painted all this in this specific room, which is a room in Delft where he lived. So it's all pretty interesting. So there's big controversy surrounding this, whether he did that or not. But anyways. So David Hockney makes this observation. What I'm suggesting is that the hand was in the camera for 400 years. Then there were chemicals in it for 180 years. And now there are digits. We can now draw digitally. I think it's a pretty interesting observation. But the hand was in the camera for 400 years. So obviously the camera, or the camera obscura, fitted with lenses, quite intricate lenses, they were along a long time before photosensitive film. So if you consider this, it's kind of, well, yeah, there were cameras. The whole point here is that technology has always kind of been a part of this goal of achieving ever-increasing realism or heightened illusion. Let's take a look at this picture. You familiar with that? Anyone seen it? This could be said to be one of the earliest, or probably the earliest example of a very complex image produced by kind of programmed computation. It's obviously not made in a computer, but it's made in a textile, like a milling machine. So in 1801, this French guy, Jacquard, invented these punch cards. So these were initially for textile patterns that you'd find on cloth, textile patterns, very simple, but quite ingenious because this meant they could be reproduced infinitely in textile mills. And competing textile mills would sometimes steal these off each other. And you could say that that was the first example of like software piracy. So you have one of these cards, you can produce these intricate patterns. So 40 years later, after this invention, this other French guy, Cartier, he did this silk portrait using, kind of taking this to another level. And this was inspirational for Babbage, like Charles Babbage, who obviously invented the analytical engine. It's like the first ever kind of schematic for a computer. He never got around to building one, but some financial issues. But very influential. It's kind of interesting that you think that this visual image, kind of an artwork, was the inspiration for modern computers, in a sense. Moving along, like 130 years. So where has all this computation gotten us? So when we finally got then frame buffers and pixels, and we could actually see the computations on a monitor, a lot started to happen in the field of computer graphics. So, and we can never get away from the University of Utah when talking about the history of computer graphics. So during like a decade there in the 70s, they basically invented everything that we still use. Like all the technology is pretty much the same. We're still in that paradigm of polygonal modeling and UVs and texture mapping. This is where it all happened. So you see, this is the first student project in which they achieved this quite intricate CG asset. This is the first ever CG asset that was anywhere near this level of complexity. So this is actually Ivan Sutherland's wife's car, her Beetle, that she drove around town with this wireframe pattern. So the students made these points, vertex points. You draw lines between all the vertices, and then you get this mesh of lines, which we call the wireframe. So this would be the wireframe version. Then the computer fills in the blanks, and we call these polygons. You have all these squares, quadratic shapes. And then a shading model will then provide the surface you're looking at. And then we can also smooth the surface and have this kind of looking like this. So Ivan E. Sutherland is kind of known as the father of computer graphics, just because he kind of headed that computer graphics division. So let's just look at some of the main inventions that happened during that period. So John Warnock, I don't know if you've heard of him, he later founded a little company called Adobe, so Photoshop and so forth. But in 1969, this was his main kind of invention, the hidden surface algorithm. You have a 3D object, you want to display it on a 2D monitor, you just have to figure out you want the background elements to be occluded by the foreground elements, basically. Gouraud, he was a Frenchman, part of the team. That's his wife. Made a quite intricate mesh, again, just doing a lot of vertex points in 1971. So if you look at these, the topology here is similar to the way we would do it today, where you have kind of radial, like a circular pattern around the eyes and the mouth. It's because we literally have circular muscles like the orbicularis oculi and the orbicularis oris around the mouth, literally circular musculature. So we want the topology to follow that pattern to give us nice deformations in animation. But Gouraud's main contribution was this. We call it gouache shading, so it's basically smooth shading. So you don't have to look at this very faceted polygonal view. But you can get a like a linear interpolation and just smooth it out. Probably, you know, logical, but still important. And this is Ed Catmull's, while he was working on his PhD thesis. Him and Fred Park made this little animation. So I think we're just going to watch that. So this would be, you know, earliest example probably of complex CG asset rigged and animated. So this was presented at SIGGRAPH, the annual computer graphics conference in '72. So this was, you know, groundbreaking stuff. The University of Utah was funded by, well, now it's called DARPA, and then it used to be called ARPA. It's basically defense budget, like unlimited budget, virtually, uh, due to the Cold War and everything. But I think the response of the U.S. was kind of interesting because instead of investing everything in defense, they actually invested a lot in, like, this wasn't necessarily direct defense spending, but it was still on the, yeah, funded by ARPA. So they just basically, their thinking was, well, we need to get smarter. You know, this is a dangerous world. So it's interesting. So a lot of good things came about from, unfortunately, but you know, this is kind of true. Sometimes in wars or in times of conflict, there is heightened innovation. Anyways, so they have this stylus which would track three, you know, XYZ coordinates and sort of get the data. They put it in the computer, and they get the wireframe with the polygons, and yeah, yeah. So this was, you know, completely revolutionary. And this was before personal computers. This was before anyone had ever seen a computer monitor. You know, most people. So a few years later, they put it in a movie, Future World. This is the sequel to Westworld, which was based on the novel by Michael Crichton, which is also the novel that Westworld, the series, is based on. So there's the hand. It's kind of a, well, I guess they liked it. They thought it was cool. I remember this was very high tech. It was revolutionary. So if they could put that in that futuristic movie, yeah, yeah. This is probably the first CG asset, you know, used in a motion picture. Oh, there's also, yeah. This is a few years later, though, so '76. So a lot of things happened very rapidly in that period. Here's another very influential paper. So this is Ed Catmull again. So he becomes quite important in the history. So there you have a face to that name. So that's Ed Catmull. And this is his family. So he had pictures of his family, and he projected it onto different geometrical shapes. And what was so special about that there was no such thing as texture mapping. So he basically invented texture mapping and subdividing. So he debated subdivision and texture mapping. It's a pretty influential little paper. So this is online, so you can just, I include all the original papers if you want to go in and actually read the papers. There's a lot of physics, and, yeah, but if you're so inclined. Let's see. All right. Fong, he was originally from Vietnam, I think, and then he moved to France, and then he joined the team in Utah. But his main contribution was the Fong shading model. So you probably heard that name. So although Gora improved the smooth shading of the polygons, the specularity, in other words, the reflection of light, sort of these highlights, still showed up as faceted results. So he improved that. So we got the Phong shading model. You've probably seen this model, arguably one of the most famous CG assets. It was modeled after a teapot, Edward Newell. So he was a British guy there, part of the team. Of course, he's British. His tea, so he decided to model his favorite object. So you see this original drawing. This is the original teapot, which is actually on display in the Computer History Museum, which is in Mountain View, California. And then James F. Blinn, Jim Blinn, basically in the CG community. You see this model is slightly scaled down, so that's something that Jim Blinn did. He just scaled it down a bit because he liked it better. So this has become, ever since, this is the teapot. It's a little bit more skewed. But his main contribution, Jim Blinn's contribution, was that he made basically image-based reflections. So you see that image on the left. He had to invent the painting program to paint it, and then he painted a little reflection map. And the way it's painted, you can see it looks a bit strange. That's because you can map that image onto a sphere. So it perfectly wraps around a sphere. And then you can put that sphere around the object. And then, I don't know if you can see it very well, but the reflections show up here. They're actually coming from this image. And this is still the way we do that kind of reflection. You put a sphere around with an image attached to it. And today you could also do image-based lighting, like IBL, if you've heard that. Basically, if you want to have a CG asset in this room, we could do a HDR panorama of the room. So it's just a lot of exposures, and then we put them together, and then not only use them for the reflections, but also for it to actually contribute to the lighting of the scene. But it's basically the same principles that were invented back here. See, now it's going crazy. Hmm? Yeah, probably. It's very strange. I'm not making that sound. I'm actually a computer. Now it's particularly bad. Yeah, that's usually the... Nope. Dope. So this will get annoying. Oh, we'll manage. Ed Catmull, now moving on from Utah. Ed Catmull there on the left, and a guy called Alvy Ray Smith on the right. Yeah, you could probably hear me if we turned this off, but the recording wouldn't, so. It's particularly unbearable this year. I don't know why. What if I put it there? Oh, I thought you were a tech person. You were going to help me. No. So anyways, yeah, so he, Ed Catmull, did the hand. He got called up by a guy called George Lucas, who had just made a film called Star Wars, to join their team with their computer division. I think we're going to fast forward here a little bit. But here you basically see there's Alvy Ray Smith, who also becomes very influential. There's Ed Catmull. And there's this other guy they just hired called John Lasseter, who had just gotten fired from Disney because he suggested something stupid, which was to, hey, what if we try 3D in our animated films? And he even made a test. They did like the first ever CG animated backdrop. I don't have that movie here, but you can find it online. Oh, it's picking up. It's very strange. I did warn you. This will be fun on the recording. I don't even know if it's going through the mixer. Whatever. Oh. Yeah. So anyways, so, you know, you can't do that at Disney at the time, so no, they fired him. Go away. We don't want this 3D. What are you thinking? And so he joined Lucasfilm, and they did a lot of groundbreaking stuff. So in 1982, this was mainly Alvy Ray Smith. Must be said to be the brainchild of this. So he basically just wanted to prove, according to himself, to George Lucas that, you know, the potential of their team, because he basically just hired them, again, according to Alvy, just to, you know, provide computer skills and provide the technical support and everything. But these CG guys really wanted to be a part of the movie making. And so they made this for Star Trek II. I'm just going to skip ahead to the actual.
A special program is used to render each of these elements in full color. The completed elements are then combined under computer control as shown here. Notice that there are no jagged edges or matte lines. The compositing is perfect. A later frame is generated similarly. In this case, one element is an atmosphere acquired during the transformation. Another is the fractal mountains. The fractal technique is a form of controlled randomness which adds a natural-like complexity to simulated scenes.
Yeah, so Alvy Ray Smith was really into this fractal,
the stars have their proper color and magnitude and are
like procedurally based fractals. As you can see here. So a lot of these simulations that would be composited together. And this was also obviously unheard of. They could not achieve anywhere near film resolution, but in the movie this was supposed to be displayed like on a display. So that's why it kind of worked. So it's referred to as the Genesis sequence. It's like it's the birth of a planet. So pretty impressive. A little CG artwork again by Alvy. Procedurally generated, like fractal based. This is a very famous image. Have you seen it? This is a didn't work. What if I do that? Nope. Yeah. But I'm going crazy. Anyways, all right. We'll march on. So this is the earliest example of ray tracing. So some of you CG people might be familiar with ray tracing. It's a technique of achieving heightened, again, on this scale of ever increasing realism and illusion. But basically, it's employing some of the same techniques. You have an image-based reflection, again, spherically mapped around, so all the reflections you see are actually from that image. In addition, though, here you have motion blur, which was a big implementation. So this is actually a still from an animation, and you see there's actual motion blur, which is very important in increasing realism in animation. So these are some early conceptual drawings made by John Lasseter while he was at Lucasfilm for a little short that they were doing called The Adventures of Andre and Wally B, which was shown at SIGGRAPH. So they all got together at this annual event called SIGGRAPH, which still exists, and I encourage you sometime to go there. Yep. No, this was actually Lucasfilm, while John Lasseter was at Lucasfilm. And Ed Catmull was also at Lucasfilm. You're bringing up an interesting point. So let's watch some of this. So this. The reason all these computer CG scientists, researchers hired in Lasseter was obviously to get that more of a raw artistic talent that was kind of been lacking in a lot of the other productions. So remember, even Ed Catmull, he did the hand. His inspiration or his aspiration when he was younger was always to be a Disney animator. So he trained to become an artist and become a Disney animator, but then he changed to physics because, yeah, obvious choice. But Ed Catmull made the observation that when they were screening this film at SIGGRAPH, they hadn't really finished the renders. Parts of it had to be shown in wireframe. It was all a little bit messy, but the audience didn't care. They really kind of just were sucked into this world, in large part due to the emotional impact. There's a story here. There's intriguing characters. There's chemistry between the characters. So that was one of the main lessons, especially for Ed Catmull, from that experience. So a guy called Steve Jobs, who had just been fired. So there's all these people who had just been fired from different places. Steve Jobs had just been fired from a company he started called Apple Computing. And he was looking for new ventures. So he was basically a venture capitalist wanting to invest. So he basically bought out the graphics group and started up a company called Pixar. So Pixar is actually a computer that had been built at Lucasfilm. So the name actually came from Alvy Ray Smith, because he thought it sounded like a Spanish verb. Or pixel, he thought sounded like a Spanish verb. And then they just combined it, Pixar, yeah. So the name kind of stuck for the company. So this was kind of the early foundation of Pixar. Ed Catmull, Alvy Ray Smith, John Lasseter, funded by Steve Jobs, who needed an investment opportunity. Because George Lucas didn't really see the potential here for fully animated content. He wanted to do visual effects, which ILM, Industrial Light and Magic, kept on doing after that. But it was probably a right move so that they could focus on what they wanted to do, is to produce fully animated content. So this is the first kind of, again, Pixar. So this is you in the back. This is the first kind of Pixar short, again, showed at SIGGRAPH. And I'm sure you're all familiar with Luxo Jr. Actually, the lamp is there. That's the actual Luxo Jr. lamp. That was the inspiration for this short. All right. Groundbreaking. So Ed Catmull, Steve Jobs, John Lasseter, obviously Pixar went on to great heights, but it's an interesting story because in many ways it's so much a part of the CG art history. So have you watched the Pixar story, the movie? The Pixar story? No, okay, so we'll also watch that movie at some point. It's a very nice documentary about the sort of the founding of Pixar. And that's Alvy Ray Smith. They hate each other. So, I mean, Steve Jobs, supposedly he was quite a character and sort of, yeah. He's more of an artist kind of type. We're gonna rush through this, I think, because of the. So I put this up. It's kind of interesting. It's from the title sequence of Westworld, made by Elastic. They also did well, they do a lot of title sequences, including Game of Thrones. But this was rendered in Octane, and now you can get Octane in Unity. So you can basically have visual effects quality in real time. Big caveat, of course, there's a lot of sampling that will need to be reduced, but currently you can reduce it a lot using artificial intelligence. So the increase of AI, obviously much more powerful GPUs, we're very close to VFX quality in-game, which is very interesting. So I don't know if you've seen this, I'm going to show this. This is a project currently at Disney. It's kind of, they've been very secretive, but now they've published this. So they're actually collaborating with Unity. Unity, for those of you who don't know, it's a game engine.
Disney and Unity Technologies have joined forces to prove that you can make TV animation with our creation engine.
We're using techniques that we've adopted from virtual reality production and from augmented reality production and utilizing a real-time rendering system to create broadcast content.
We are making 3 short films based on the Big Hero 6 property. We're telling the story of Baymax as he falls asleep and goes into a dream state.
Getting to see what would Baymax dream is something we wouldn't do in the series probably, and this approach really feels like it's taking Baymax to some new place.
It's a show about technology. That's why it was really a marvelous fit that a real-world new technology is being used.
It's a new way of creating content that hasn't been done traditionally in the past.
In the traditional waterfall approach, you have dependencies between departments. Your lighting department is dependent on your animation department and so on and so forth. The wonderful thing about real-time content creation is that it allows for multiple parallel workflows to happen simultaneously.
All the departments are working at the same time together, and the director can look at everything at the same time.
Real-time animation production is going to change the world. There's no more render farm.
Playback is instant.
From the moment that you get inspired and you get an idea, you can see it immediately in front of you.
You can go, you know what, midday isn't feeling that great. Let's just go to Magic Hour. In an instant, you can hit a button, see what everything looks like at Magic Hour.
There's a part where Baymax's rocket fist comes out and hits one of the bed bugs, and Simon goes, oh, what if we punch in on that? And this is like the 11th hour. This is due tomorrow.
Normally, this idea of punching into a thing that's moving at high velocity would have taken a while, and Not did it in about 1 minute.
And it went from an idea that was like an 8 out of 10 to something that was much stronger because we had this discovery on the moment. When a director now says, what if, you don't see people go, because it's just, okay, what if?
You can gamble a little bit more creatively and come up with those happy accidents to get to an even better result.
When you get these assets into Unity, you have future-proofed your investment.
Now that you've created assets, you can use those sets and those characters in other experiences.
We can create AR experiences, VR experiences, all from the engine because it's already in there. If you look at Disney's history and if you look at the DNA of the company, it's all about experimentation.
We're always looking to reach out to new technologies and new platforms to advance the storytelling ethos.
And when we saw the power of producing content on real-time engines and the potential of what it could do in the future, we realized that this was right within our core wheelhouse.
Animations have gone through transformations. 2D to 3D when we started doing CG animation, and this is the next transformation.
I think this is the future of animated filmmaking, a new way of telling stories.
This is very interesting. And who's in charge of Disney? Ed Catmull. And John Lasseter. But John Lasseter's leaving due to some Me Too things. Unfortunately, later this year, I think. But anyways, what's that? Yeah, yeah. It doesn't go well with the whole Disney concept. I don't know. Anyways, yeah. But there's a book on your reading list called Creativity.Inc., which is by Ed Catmull. It's basically on how to structure creative collaboration, which is obviously something they've been very good at Pixar. And they've implemented that same strategy at Disney when they also got to be in charge of Disney. It's a very interesting book, and I think it's very relevant for anyone who wants to try to collaborate creatively. So I would recommend getting that book and just read it. Because we will be doing a lot of collaborative productions eventually, so we'll be using some of those like a case study, like kind of look at the Pixar kind of mindset, because they've done some things right. More real-time stuff. This is from Unreal, so another game engine, which is free, but you then have to pay them a lot, not a lot, but percentages if you make over $100,000 or something.
Hello, I'm Siren, and I'm a digital human. I was created by an international team of artists and engineers who wanted to challenge our ideas of what a synthetic human could be. I've got state-of-the-art real-time graphics and an unprecedented level of detail in my eyes, skin, and hair. Cool, right? But I'm more than just a collection of fancy pixels. I'm actually being driven by a real human actress and her dynamic motion capture through Unreal Engine. So what are you waiting for? Come meet me at the Vicon booth and see for yourself.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector.
If you ask me, who's ever in charge of this place should be transferred to Hoth.
What?
What?
You think she heard us? Yeah, I think she heard us.
At least we blend in for once.
Tomorrow. And tomorrow. And tomorrow. Creeps in this petty pace. From day to day. To the last syllable recorded time. And all our yesterdays have lighted fools the way to dusty death. Out. Out! Brief candle! Life's but a walking shadow. poor player that struts and frets his hour upon the stage, and then is heard no more. It is a tale told by an idiot, full of sound and fury, signifying nothing.
All right. So it's real time. Getting pretty good. This was rendered, well, on 4 GPUs, like real time, but using 4 GPUs. Now you can do the same with the new latest NVIDIA, using only 1 GPU. So I'm not sure, whatever it's called, the latest. Yeah. They just announced it. Like, oh, yeah, that one. Yeah. So, but the potential here, just to sort of think a little bit ahead, you know, what's going to happen in terms of VR, content for movies and games, obviously blending or becoming the same. And another kind of interesting development is something, well, this artist, Mario Klingman, he calls it neurography. It's kind of taking neuro and photography, putting it together. I think he's using 2 neural networks, so deep learning, artificial intelligence. So one of the, at least some of these neurographers do that. So they have one neural net sort of making art, and then you have another neural net commenting on the art. So you have both the art critic and the artist both being artificial intelligences, and then you can create art with it. So he says, I'm doing creepy right now because I can't do non-creepy. In 2 or 3 years, the creepiness will go away, which might make it more creepy. In other words, once you get to the point of just photorealism, but it's like a painting, but it's not made by a human. It would be an AI made the art. And is that art or is it not? Don't know. So he says, like a photographer goes out into the physical world, selects a motive and frames it, I travel into the latent spaces of the models I trained, in other words, the AI neural nets, and bring back the images I find there. I thought also it was an interesting way to look at it. So he's a human, but is going into this other world, sort of this AI neural net world, and he's finding interesting images, just like a photographer to go out in the real world and find interesting images. So this was a project he worked on, a music video. Just going to play a little bit of it. So he's right, it is kind of creepy. But it's just kind of interesting to always kind of keep up with the latest trends and try to extrapolate, like what do you think will happen in 5 years? You know, what's sort of likelihood of things happening? So having it's part of it.
See things falling apart, but as they say, you gotta learn to let it go. Let go of the things you really want the most.
Hi.
And if love is true,
So but I think this will be very interesting and might change. Obviously, AI in general is going to be quite disruptive, but especially also in the field of CG. Hey, let's. Yeah, you can watch that tonight if you want before you go to bed. All right. Yeah. So, anyways, image on the right, ZBrush artist Chris Costa. Dick Smith is like a FX kind of effects guy. it's kind of homage to him. But just the point being that the image on the right, you don't have to like, you know, mix your own oil paints or build your own canvases or do all of these other technical things, which or have too much knowledge of physical cameras, which you would have to on the image on the left. But there's a lot of technical ground you have to cover in order to achieve something like this also. So it's just two different mediums. So in this course, we will be spending a lot of time looking at gray, boring cubes and the like. You know, it's very technical. It's not the technical level is not high, but it's the content is purely technical. So I don't know if it should be called CG art, but it's just like the foundations you would need to understand and to be comfortable working in CG, at least while we're still in this polygon paradigm, which we're still in. You know, so being able to kind of work with polygonal meshes, spot errors, like unmerged vertices, flipped normals, non-manifold meshes, you know, good UVs, spotting overlapping UVs, flipped UVs, all these things that always occur that would have to go in and fix, basically. So that, you know, that's the same regardless of which software you use. So again, I don't care whichever software you want to use, but the pipeline here, we're using Maya, so that's what we use. And we'll be using Hedis UV, which is a little application just for UV unwrapping, and just a very little bit of Photoshop. So, how's your Photoshop familiarity? Okay. All right. Well, we'll get. But you have other classes right now, which art classes or something. You have digital art or painting. Yeah. So that'll be good. Yeah. Okay. So. Did I have more? No, just a few references for all that. But I think it's like I said, if you always make it a habit, sort of keep up to speed on try to, you know, what's happening lately. Now it's happening so rapidly. You know, there's something new all the time. So this big thing, you know, all the real-time examples. You know, the big change here is real-time ray tracing. That's what allows this to happen. Like back to the picture with the billiard balls. Now you can have real-time ray tracing, which changes a lot because you can have subsurface scattering and, you know, like sophisticated calculation of light transmission through different media. So the technical aspects of it are pretty much the same, and we're still following a lot of the same paradigms of which were invented at Utah, all those early examples we looked at. All right. So we'll take a short break. I think we'll take like 10 minutes. And are you okay staying a little bit longer than, I mean, I think we're in here until 11:30 or 12. I don't know. All right, so we might go until 12. We'll see what happens. I'll probably keep it short. But let's take like 10 minutes and then we'll just get started in Maya a little bit. So we'll do that. All right. Let's just get started with Maya. This is Maya. Oh, question. Yes. What's that? Yeah, I will be posting the video, the recording online. Yeah, I'll upload it to YouTube and then I'll post a link in Canvas. So, yeah, welcome to Maya. So there's a lot going on here, a lot of menus, a lot of crap happening. Our approach will be very pragmatic in the sense that I really believe in solving tasks like while you're learning. So that's why I give all these tasks. Like next week, you're supposed to deliver this primitive city. And obviously, I honestly don't care too much about the primitive city, but it's a nice exercise to familiarize yourself with the navigation, the various polygon primitives, and how you can transform them. So It's just better to have some sort of concrete task to complete while you're learning. So don't be afraid to just get started trying to achieve these tasks, and there will be a lot of issues and problems, and that's all part of it. So there's a lot going on. You have some menus here. Like all these menus, mesh, edit mesh, mesh tools, blah, 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 they're all related to modeling. So obviously this is where we will be spending all of our time. But then you have rigging. If you click here, this will change the menu set. So now these refer to rigging controls. Animation, you have animation controls, FX, particles, and simulation, and so forth. Rendering, different things. So, but for now, you can leave it at modeling. Just so you know, if the menus have changed, this is the main menu selection. And then if you look here, window, UI elements, user interface elements. All these menus you can tear off. So if I click these little lines, I can actually tear off the menu. You can do that with any menu. So just tear it off like that. So UI elements, status line, that's the one on the top. So I can turn all of these off like that. So let's leave some of these on, but I'm going to turn off the time slider, which is this one, and the range slider because they're only useful in animation and we're not going to be animating. And also the command line. So this is where you can actually insert little pieces of code. So either in MEL, which is my embedded language, or if you click there, Python, if you know how to program Python. It's a recognized language and very much in use in VFX. So if you're into programming, I highly suggest Python. Okay, so UI elements. Let's create a cube. There's the cube. It's a polygonal cube. Poly modeling, we have a little shelf here. You can also go create polygon primitives cube. So these are all polygonal primitives. So there's a difference between polygonal primitives and these curved or like NURBS. These are technically different from polygonal objects. So we're not going to be spending too much time with curved surfaces. We will try them and convert them to polygons. But for the most time, the important thing in this course will be to really understand polygonal modeling and be comfortable with a polygonal mesh. So the navigation here works that you have to press Alt. So I have my left hand just placed on Alt, Alt, Shift, and Control, like on the left side of the keyboard. So if I hold Alt, I can use the 3 mouse buttons. So you need a 3-button mouse. If I use the left mouse button, I can rotate around. Middle mouse button, I can like that. And right mouse button, I can dolly in and out. So this is actually moving the camera in and out. So you'll get that. If you're new to 3D, this will be a very unfamiliar, obviously. So you will have to just train your brain a little bit and just basically spend time in Maya and try to navigate. Which will take some time, and then it will be like second nature. You will not think about it. So that's kind of the challenging part here when you're starting out. There's so many things happening at once, and usually a lot that could potentially go wrong. Like you hit a button and something weird happens, and what's going on? So. But gradually, so when you're on the lab and so forth and something happens, don't hesitate to ask whoever's next to you. So we really want to develop this mentality where you're not just in your own bubble and in your own computer, but that's the reason why we're here. Otherwise, we could do everything online and just, it's part of the community. So if everyone helps each other out, you'll be rewarded for that, I think. So this is currently the shaded version of this polygonal object. there's a way to change the background colors. I'm just going to cover that. Alt-B. You can toggle between different background colors. This might be more convenient to actually see what you're doing if you're working with the gray models. That's Alt-B. If I press 4, I can go into wireframe mode. So now we're only looking at the vertices, the edges, basically making up the mesh. That's the wireframe. So we just ignore the shaded polys. And then press 5, we're in shaded mode, so we can see the shaded mode. If we press 6, we would be in textured mode, but there's no textures, so we can't see any textures. All right. So 4 and 5, just remember that you can toggle between. Oh, they're also here on these buttons, but 4 and 5. And if you press 3, that will actually subdivide the model. But we're going to look at that in a couple of sessions because, it takes a little bit of training to get used to how that subdivision algorithm works and how we can influence it using edges and so forth. So we'll get back to that. But just know that if you press 3 and it turns into a blob, you can press 1 and you can go back to the polygonal object. Right. So those are all on the number keys. Okay, and over here we have an important window called the channel box. Let's look at how we can manipulate this object, how we can move it around. So if I press Q, W, E, R, like the first 4 letters on the keyboard, those, just get used to those. That will alter between just the selection tool, this one. If I press W, now we're in move, E, rotate, and R for scale. So our hand just always placed on the left side of the keyboard, and I have all those right here. So eventually you don't think about it, it just happens automatically and you can navigate very quickly. Also, if you find that, what happened to my cursor or the transformation tool, then you can do that on plus and minus. You can make it bigger or smaller. So this works that, obviously we have 3 axes. It's the X, Y, and Z axis. So if I press the mouse and just hold on the navigation or the transformation tool on one of the axes, I can move it only along that axis. And you can notice in the channel box that the numerical values here will update. So if I go here and I enter 0, it's going to pop back to 0. So I can also use the channel box as a numeric input. So let's say I want to translate this 5 units up. Oh, there it went, 5 units up. So the units here, well, obviously they're arbitrary. They could be anything. They're just units. So we're going to look here at the grid. So we have 12 units here, but this is where you can update the grid. We'll look at this later, but essentially we do care about the working in the correct scale and so forth. We're not going to care about that for now. But technically, right now it's set up so that every unit is, I think, 1 centimeter. So we're technically working in a very small scene, but it doesn't really matter for now because it's all relative. It's all polys. Doesn't really matter at this point. But just know that you can enter numeric values and it will go along this coordinate system. So moving it around, we also have some snapping functions that become very handy, and those are also sort of on the first like X, C, and V buttons, X, C, and V. So you see here, they activate these snapping functions up here, and that's snap to grid, snap to curve, and snap to point. So if I want to move this this cube around pretty quickly along the grid, I can hold X and it will snap to exact grid units. Like you see here, 1, 2, 3, 4, 5, also up. So that's very handy. So this point, all right, so that's move, and if I hit E, that's rotate, You can go like that. If I click here in the middle, I can rotate it arbitrarily, but not only around one axis. Also with the move tool, if I just click in there, I can move it freely. And then again, whenever you want to reset this, you can select all these, just drag the mouse down like that and press 0, and that will just reset everything. So this point, we call it the pivot point. That's because that's where the area around which the object will pivot when we rotate. And there's a way to change the location of the pivot point. It's a very simple way. You can just press D. If I hold D, whoops. If I hold D, you can see the cursor there changes a little bit. Now I can basically alter the pivot. So I'm not moving the object, I'm moving the pivot point. So let's say I want to move the pivot point exactly to the bottom of this cube. I can hold D and I can hold V. This time not X but V for snap to point, and then I can move that and it will snap down to the bottom vertices. Okay. So V, or I could hold X and snap it back up to the grid. I'm using that snapping function. So these snapping functions are very handy. So I hold D and I start moving it along Y. So this, right now, whatever I do to the mouse, it will only move along the Y axis, like up and down axis. It's not going to move anywhere else. So that means I can just hold D and I hold V, now snapping to point, and only along this axis, move it along, and it will snap to whichever point it's finding along that axis. Currently, I only have one object in the scene, so obviously it's only snapping to this object. So then, if I wanted to place it on the grid, I can now hold X. Now I'm not going to alter the pivot. The pivot is normal. I'm just holding X to snap to point, or snap to grid, and I can snap it on the grid. Quick and easy way to do that. So let's say I want to, now I want to center the pivot back. Like I want it to be in the mathematical center again. So what I'm going to do here, I'm going to make my own shelf. And I suggest you do the same like on the lab, because it's a nice way to keep track of these new tools that we're going to be using. So here we have all these shelves. You know, this is for poly modeling. You know, you have all these buttons, sculpting, all the. What I can do here, go. Where do I do this here? Yeah, so press that little gear icon and I can do new shelf. So it's going to call this jewels. Okay, so there's my shelf. So the first thing I'm going to add here is for center pivot. So I'm going to modify center pivot. So whenever you Control-Shift-Click something, it will add it to that shelf. So Control-Shift-Click, it will add it to the shelf, and I can center the pivot. It was behaving so nicely. All right, so then whenever you need to reset these values, that's also kind of important. We use freeze transformations. So that's also under modify. So center pivot, this is also very important. Freeze transformations, I'm going to Control-Shift-Click it. So I can click there and see these values are back. This is important. Let's say you're modeling and sometimes, you know, this will be over here. And this will be the default location for that object. You know, just imagine you have a CG asset and you have various parts. And this part over here, that's the point of origin for that object. And then I need to freeze, and now it's there. So if I move it off, if I go back and click 0, it will snap back to that origin, not to the center of the grid. Okay, another thing that becomes very important as we work. So you see here in the channel box, if you go down to the very bottom, it has some inputs. So we're not going to get started using modeling tools today, but eventually, like next week, we start using tools, and everything you do will add up here under the inputs. That's only useful, I think, it doesn't really work too well, but it can be useful in the latest operation that you did, because you can go into that operation and then alter it. So so let's just make another cube. And look here at the bottom under inputs, we have, this is the operation. The operation is polycube. I just made a cube. But here we can update that operation. So if I want to add some subdivisions, I can use the middle mouse button as a slider, and then it will update it like that. So if I want more subdivisions, that's how you can do that. Or if I select all of these values and just go at once, I can increase a lot of subdivisions. This is not introducing any sort of curvature in the subdivision, like the subdivision algorithm that we looked at, that Catmull invented. But basically, this is just adding more polys, just subdividing each time, quadrupling each poly, right? So very quickly, you get it like an exponential growth. Anyways, but the point here is just that at the bottom you get a lot of inputs. We don't really need all those inputs, and it can cause trouble. So we need to get rid of them, actually, as you work. So this is very important that we delete history. So it's under Edit, Delete by Type History. So I'm going to Control-Shift-click that. So now we have a little button. So if I click that, it will just get rid of those inputs. It's very important to do. If you don't do it sometimes and you save the scene and you open the scene back up, all sorts of strangeness can occur. So just delete history. It's actually very kind of crucial in Maya to keep a habit of doing that. Okay, so we have other primitives here. Obviously, you can have a look at them. This is this sphere. And it looks very smooth and very nice, and remember back to Garo shading, like we get like a smooth linear interpolation of all the polys. It just looks smooth and nice. That has to do with the, we'll get back to this, but I just wanted to quickly mention it. That has to do with the surface normals. So we can actually, if I go in here into the normals, I can say harden edge, and now we can actually see it does not apply that smooth shading, so we can see more clearly the polys. But anyways, we'll get back to that. But there's a lot of these, not a lot, but a few of these primitives. We'll also eventually have a look at how we can sometimes start from planes instead of starting from cubes. Working from planes can be very elegant. Like you can achieve complex shapes quicker and then not have to worry about the depth until you have to, essentially. So, all right. So far, we've been moving this around in object mode. So if I right click and hold, on the lab, this will be a little bit nicer because I'm working on a limited resolution here. The menu here doesn't really work because this is a gesture-based menu. Like essentially all the menus in Maya can actually be accessed through this gesture-based menu set. So you're gesturing with your hand. And so this is it's designed so that I can just quickly go like that to the right, and then you're in object mode. If I go to the left, you're in vertex mode. I go to the bottom, you're in face mode. But here you can see I have to hold and go up. So it's not set up correctly. This will be better on the lab. But essentially, if you gesture up to the right, that's the object mode that we were just in. So I'm selecting the object in object mode. I can move it around as an object. If I right click and hold and I select vertex, I'm in vertex mode. So if I'm selecting, these are the vertex points. So all these vertices. So I can move them around. I can also scale them. So if I scale all of these together or apart, I can scale in one of the axes at a time, or click in the middle, it will scale everything uniformly. So if I move all the vertices, let's do that. So I move all the vertices up. This is not something you would probably typically do, but if I move everything up and I go in object mode, you can see that the pivot point is still there and the values are still 0 because I haven't moved the object. So the object's position is controlled by its own little transform node. So if you think this is what we're looking at here. It's not the placement of the vertices. So the vertices and the objects it's like a different approach. But I can move all the vertices independently of the object node. Then I have edges. Edges are just obviously the connecting lines between the vertices. I can also move the edges around I can scale them towards each other. So this is exactly the same as doing the vertices. So I think you'll find that once you get used to this, that for the most part, when you're manipulating the shapes, you will be using the vertices, like selecting the vertices and manipulating them. I can also select the face. That's just Maya's name for polygon. So I can select that and scale it. It's practically doing the same. So those are the three main components. So edges, vertices, and polygons, or face. Vertex face, give you that. Don't really use that to manipulate anything. So the main components, face, vertex, edge, and you have the multi-tool, which will allow you to access all of those at once. So now that I can select the vertex, theoretically, yeah, like that. One thing also to bear in mind, like if I'm in vertex mode and I start selecting, is that this will select initially through the object. So if I go to wireframe, press 4, you'll see that that vertex is also selected. So it will just select vertices everywhere within that range. There is a way to set up the selection tool so that it will not do that. Yeah, I forget. Let's get back to that. There, you know, if you double-click these tools, there are settings for all the tools. Oh, that's actually kind of useful in case some strange things happen. One of the things that usually happens is that the move tool will suddenly get like soft selection enabled, and then when I try to now move a vertex point, I can't because it's using the soft selection mode. So whoops. So this usually happens. I don't know what the hotkey is for that. I should know these things. So there's a sphere. So the soft selection is obviously sometimes nice. So now I can do that, and I have this soft selection. That's what it's for. But if I'm in a cube and I want to move a vertex, it's definitely not useful because it's moving everything. So just remember that, you know, if these strange things happen to some of the transform tools, you can double-click these icons and then go into the tool settings, and then reset tool. That will just reset it to the default, and now it should, yeah, or it didn't. All right, so in this case, you would have to be aware, I guess, of the soft select. Does not. I guess this should be, the default is that it's not enabled, so you would think logically this would be resetting it. But this is kind of Maya, it's a little bit clunky, there's like old pieces of code, and it's very, it's not the most structured of softwares. But it's in use in a lot of places. It's just very, it's implemented into a lot of pipelines. And it's very customizable. So like I mentioned, if you're into coding, if you do Python, you can do a lot of your own customizations. It's very open that way, but it's not the most user-friendly experience, perhaps, initially, but then you'll get used to it. But anyway, so that's one of those little things. You have to know then about the soft selection. If that happens, go in there, turn it off. Another way to access the tool settings, or some of them, is to hold whichever hotkey. So for the move tool, that's W. So if I hold W and I click and hold left mouse button, I can access them here. Some of them. Let's see if is soft select there. No. Oh yeah, it's there. So you see everything is kind of in here in these gesture-based menu sets, which can obviously save you time. I can just go like that, boom, boom, and there I'm in soft select. It's pretty smart the way it's designed. So essentially you could work in Maya without using all these different menus. And some people do. See, if you want to go in full screen mode, you can hit Control Space Bar, and that will take you into full screen mode. And that will just get rid of all the UI elements. And then go back. All right. What else? Questions? Yeah. Yeah, of course. Yeah, you can export it as like an OBJ. It's just an old school, very stable format if it's only geometry. So that, or FBX or any other type. But if it's just geometry and UVs, you can export an OBJ, which stands for object. And it's very versatile. It will read in Maya just fine. If you have like animated content, there's a file format called FBX. Yeah. Now, in addition to these classes, we will have lab sessions. So normally we would have had a lab session afterwards, following this lecture. So essentially doing everything again, but then you doing it, and with me helping you out, and also with Luai, well, sometimes he will be there. So, but I actually kind of, this becomes a question of which approach you choose, but I like this thing where you first actually just observe it and then not worry too much about it. Well, you pay attention and you then internalize it somehow and then you try it. Like I personally like that style better. So, but it's debatable. But yeah, definitely you have to do it yourself, obviously, yeah. So we will have lab sessions. But it will be this Monday from 4 o'clock, or coming Monday from 4 o'clock till, no, what did I say? Yeah, 4 till 6:30. Yes, on Monday. No, I know. It needs to be updated because we need to get a little lab session in before the next lecture, which will be already the next Wednesday. So, but yeah, totally. Obviously, you do have to. It's a very practical approach. You have to try this as soon as possible. So ideally, we would go right into the lab today, but I heard you had some sort of thing happening in Levanger. There's like some student activity. Oh, you do? I heard everyone was going to Levanger, so I couldn't. Well, there is some student activity, if you want to join. I think it's happening in Levanger. So I hear. Anyways, right. Other questions? Yeah, so yeah, 3D Studio Max to Maya, no problem. Like all the other softwares you can import here and there, no problem. Yep. Which controls? To change, to customize the shortcuts? Yeah. Well, yeah, right. Yeah, there might be a way. Yeah, there's a hotkey editor. So in here you can customize anything. So you can basically, yeah, you can make your own hotkeys. There might be a 3D Studio Max style template. I don't know, maybe. Should be. Which is kind of a useful Maya default. Choose category. No. No. You can Google it. There might be a way. I mean, some softwares have this where you either choose Maya styles, 3D Studio Max, or whatever you used to. And there should be something like that here, but it doesn't seem that it is. Yeah, so that might be what you'd have to do. I've never tried it. Yeah. So yeah, so that would be useful for you 3D Studio Max people if you could have the same hotkeys that you're used to. Yeah, so let us know if you figure that out, how to do that. All right, other questions? So this is sort of the basics that you'd have to get used to, the navigating around, manipulating the components. And next time we'll start looking at, right now, obviously we just made a cube, we haven't done anything to it, so it's like a legal mesh. There's nothing wrong with the mesh. The mesh just means that the 3D object. There's a way to get, if we go to display, heads up display, we can activate this little thing called poly count. So it will show you the total poly count, the number of faces, edges, vertices in the currently selected object. That will be here. This is the total in your scene. And currently we just have one object. So. But also if I select vertex point, you'll see that okay, it's only one vertex point currently selected. If I do 2, now it's 2 vertices currently selected, or 4. So if I select there, and I can go yeah, so you'll see me struggling with these menus because I'm kind of used to the old setup, but I should be used to this by now, but I'm not. So let's see, we gotta detach this component. So now I just detached, you don't have to worry about this for now, and we'll look more at this later, but now you can see that it's actually 3 vertices. And that's because we have 3 edges coming in here. Now we just split them so they all have their own vertex point. And then I can move them if I want to, like, apart, so you can see that more clearly. So we opened up the mesh. So now we're looking into the mesh. We can see the back faces. And they're all black because we don't have two-sided lighting turned on. So if in lighting, if you go here, two-sided lighting, you can also see the back faces. But why it's kind of turned off initially by default is because it's very useful, actually, because when we're constructing models, we don't want to see the back faces. So we want to construct a continuous mesh in which we only see the front faces, the polygons, they're the normal pointing towards us. So that's how we can split it, and if I select it, you'll see that it's 3 verts. Also, if I were to subdivide this, strange things will happen. So this is what we'll be looking at starting next week. But I can then merge these back together. So I go edit mesh, merge. So now they're back to 1. And doing this kind of stuff, now it becomes important then to delete history. And now I'm back to, again, I have a clean, nice mesh. Okay, so what I want you to do then is just to start experimenting and moving. So let's see, I can hold D, I can hold V, snap to the bottom, hold X, snap to the grid, and scale this up. So if I copy this one, Control D, I can copy objects, duplicate, and then scale. If I hold Control and scale in any of the axes, it will actually scale not in that current axis, but in the other 2. So if I hold Control and scale Y, it will scale X and Z. If I hit the middle, it will scale all at once, but if I hold Control in one of the axes, that means ignore this axis, but scale the other 2. So I can go like that. Yeah, so what if I wanted to try to make a, let me copy that again. So if I want to make like a roof, I could raise that poly and grab the verts here and then scale them in. Kind of like that. So this is what I want you to do, just experiment with the polygonal primitives and move the components around and try to make this primitive city where you're building these simple objects, which would look phenomenal if it were 1972, but you know, unfortunately audiences are quite spoiled today. If you make a cube, again, and we go to the bottom, so I showed this initially, you can go to the very bottom where it says inputs polycube, and I can do height. This will introduce more, subdivisions height. This will introduce more subdivisions. So I can use middle mouse button and introduce a couple of subdivisions. So like technically what it does, you can see what it does, and go to edge mode. It will introduce edge loops. We call these continuous rows of edges. They're edge loops If I double click on an edge loop, it will select that entire edge loop. So if I hit 4, you'll see I'm double clicking, I'm selecting that entire row of edges, that continuous edge loop. So this also means that I could potentially then grab some of these vertices, but not all of them. So if I wanted to, let's say, try to implement some more cartoony, like make more like a curved version, I can start manipulating these vertices, and this is sort of the basis of polygonal modeling, like getting used to manipulating vertices to change the contours. So now we change the contours that way, but maybe I want to look over here and I want to try changing the contours this way. So I can move them, or I can select all of them and scale them towards each other. So that's something to remember, that sometimes you can scale vertices towards each other to make a transformation. All right, so let me put that on the grid. So I can hold D and X, or V and X. Oops, not D. V. Go out of that, and X to snap it on the grid and scale it up. So obviously, the more edge loops I had, the more vertices I would have access to influence the contours. So the only reason really for introducing a lot of edge loops or a lot of vertices is that you want to change the contours. If I just do that, like a lot of edges, and only to do this, that's quite excessive. You don't need that. You could do the same with only a few of these. So let me get rid of all the ones we don't need. So the way of determining that is just to see which of these edge loops are not actually influencing the contour change. The contour change being only here. Well, all of these additional edge loops are not really affecting the change at all. You see, these contours are completely flat. All these additional edge loops are, in that sense, not needed. So let's see if they fix this if I just click backspace. No. So in Maya, if you select an edge and click backspace to delete it, it will leave behind all these vertices. You don't want to do that because this creates, these are no longer quads. So quads referring to polygons that have 4 edges. We never want to have polygons in our models that have more than 4 edges, or more than like 4 vertices or 4 edges, basically. All right. We can sometimes, well, technically everything, all polys are actually tris. Like technically they're all triangles. So you can also have triangles if you have, in your solutions. But you never want to have any polygons when you're modeling that has more than 4 edges. So in this case, since it left behind all these vertices, we actually have a lot of edges because this creates all these edges. Although it's not that apparent, these are all now little edges. So you see if I just select all of them like that, you see in the poly count here, 3 edges are selected. There's a quick way to actually get rid of all those vertices that are not influencing at all. I can just click backspace and I will actually delete them because they're not attached to an edge and they're gone. So I can't really delete these ones because they're all attached to edges. But this is not attached to a single edge, so I can just delete it. If I select everything, it will delete all the vertices that can be deleted, which means all the ones that are not attached to an edge. Yeah, so Control Z can undo. I can undo, go back in time. So rather than just clicking backspace, then I can click Control backspace, and that will delete the edges and the vertices in one operation. So just remember that if you want to delete an edge or an edge loop, just hit Control backspace, and that will get rid of everything at once. And again, remember to delete history. Like eventually, you just want to make a habit of just deleting history. All right, so yeah. So there are other ways, obviously, to introduce edge loops and extrude faces and all of that, and we'll be looking at that next week. But for now, the challenge here will be how far can you take this using polygonal primitives, but then also with this added option of going into here and adding more divisions. You can do it either, like all these operations, even for create cube, has this little option box. If you go in here, these are the options for the creation of the cube. So I can initially set this to be like 4 divisions in the height and create it, and that will create the cube like that. Or like we saw, I could do it after the fact in the channel box. And we can reset this. This is just the default for the cube. Like that. And all these different options, you can use middle mouse button, and it works like a slider. So I'm sliding left and right. See the numbers update. And there's this window over here. This is the outliner. This is a very nice and easy way to keep track of everything that's going on in your scene. So these items here at the bottom, the light sets, they're just here by default. You don't have to really worry too much about them. You also have 4 cameras here that are here by default. The 4 cameras being the one we're currently looking through, which is the perspective camera. Then if we hit spacebar, you can actually see the other cameras or the other camera views. So these are orthographic camera views, meaning that they're actually lacking one axis. So all of the orthographic views only have 2 axes, right? So there's like literally only 2 axes in each of those views. So this is something you will eventually start wrapping your heads around, but let me, okay, so I can select, these are the 3 polygonal objects that are currently made. I can select them from the outliner, and you see that they become selected in the view. I can also select them from here, and they will become selected in the outliner. But if I select them from here, I can go Control H to hide them. Now they're gone. You see they're grayed out in the outliner. So I can select them again and hit Shift H to make them appear. Yeah. So in Blender, you're using the orthographic views. View. You can change the, yeah. So, well, yeah, you could. I don't know why you would want to. You can. You can select this camera and you can change it. So you can basically, you can turn any camera into an orthographic camera. So if I go into even the perspective camera here, if I go into its settings. All right, so anything in Maya, you can access all its attributes in the attribute editor. So it's a very important window. It's not this one. This is the channel box. It's just an abbreviated version. But if I hit Control A, this is the attribute editor. It just has all the attributes of any given object that's currently selected. So if I go here, which is the current, this is the perspective camera, and I go select camera, I have all the attributes for that camera. So we can see that it has a focal length of 35 millimeters. Should be like human vision, you know, roughly from 35 to 50 millimeters, kind of standard lens, right? If you're into photography. And then an orthographic camera then would virtually, you know, you can make this be, no, not depth of field. Where was that? Well, let's see. Well, essentially, the more, you know, the more I increase the focal length, initially, the less depth you have, like the less dimension you have. But you can make this be virtually without that. Let's see, I think there's like a little checkbox. Yeah, there. So now it's an orthographic camera. And then it's virtually missing, it's just flat. It's missing that axis. So it's a two-dimensional world. So this way you can, essentially you can move anywhere you want and just turn it orthographic if that's what you wanted to do. Right. Yeah, spacebar. So yeah, all right, so let me hit Control A again, so to go out of the attribute editor. Yeah, so spacebar, I can go in and out to view all of them at once, or if I hit spacebar in one of them, now I'm in that one. And so we can also, let's see. Yeah, now I messed it up. I shouldn't have done that. I'm sorry, what? Yeah, there used to be a little cube there that you could. I don't know. I think you're worrying too much. This will be all right. I mean, it's just, yeah. Yeah, there used to be a little cube like indicating where things were. But essentially, you have this axis indicator at the bottom left. So you can see this is the z-axis, the x-axis, and the y-axis. And when we're working with models, we're going to get used to using the z-axis as the depth, which will always be the depth. And the front of the object will actually always be facing z. So the front, let's see, so the front of this house essentially, well, let's say this is the front. That's what you're looking at in the front view, right? Side view, top view. Right. Anyways, so let's, all right, so let's hide these again. So if let's say I make 3 cubes. Again, let me just move this there. And let me snap this here and there. I'll just move this over. All right, whatever, let's do it that way. So using the front view. So obviously, with perspective, these will recede farther back depending on the focal length of the camera. So if I have, again, I go into select this camera. The focal length of the lens will influence the depth. So if I have a very, like a fisheye lens, you know, obviously the dimensions are exaggerated. Or if I have a very, like telephoto, you know, the dimensions are much less obvious. But typically, like the default is like 35 to 50 millimeter, usually when we're modeling, which would be sort of the normal focal length. But then what do you think this will look like in the front view? Flat. Flat, right? No change. So if we go to the front view, yeah, so that's what you're looking at. So there's virtually no dimension shift because that axis is literally not here. There's only 2 axes here. So whenever I'm moving these things around, or these cubes around, it will not move in the z-axis. So that's why it's actually very useful to use these orthographic views while we're modeling. Because if I'm particularly concerned right now with the dimensions of each of these objects, which are similar, I mean, or identical, maybe I rather want to be working in an orthographic view, you know, for the placement of them also. It's much easier here. I can just look, I want them like that. Perfect. That's actually a bit harder to do over here. So I'm like fiddling around. So getting used to the orthographic views, here's the top view. It's obviously a very central part of modeling, which you will, so just press spacebar. Just try them out, see what happens. Just remember that if you're like struggling with the placement of objects, I think it's worthwhile considering using one of the orthographic views. So where were we? Yeah, okay, so, all right. So hiding things here, so I can make things appear back, Shift H. What's that? No. All right. So the final thing we're just going to have to cover here, because you need to apply it when you're doing this primitive city, is that you can obviously name things. You know, some people are really obsessed with naming every single little cube initially. I don't usually name anything until the final stages, because usually I'll be like working everywhere, so I'll be sending it to Hedis or ZBrush or wherever it goes, and here and there. And so the naming becomes a little tedious to keep track of. So I name whichever object I export, but I don't really bother too much with the naming here. So you'll hear different things, but obviously in the end, everything needs to be named. But you know, whatever it is you want to do. So, all right, but let's just cover very quickly grouping and keeping track of groups in the outliner, and that will be sort of the last thing. So if the outliner doesn't show up, it is under window outliner. So this is the important window you need. So I can select the objects. Nice habit then would be to freeze or delete history, freeze transformations. I can do that on each of the objects. So now this is the new default position for this object. So if I were to move it over there, I can just go and zero it out, and it will be back. And yeah, and also I could center pivot on each and every object if I wanted to. And then Control G, I can make a group. So whichever is selected will be now in the group. I could call this house 1, whatever. So now I can copy this entire group. So if I Control D to duplicate, it seems like nothing happened. It's just because everything's existing at the, you know, dead center, so everything's in the exact same location. The only way to really tell is in the outliner. So the outliner is really necessary for you to keep track of everything that's in your scene. But now I can obviously move this to the side. You see the naming actually updates. If I include a little underscore number, it will iterate each copy. I can do that. I can also, so basically, remember the cube was its position and all of its transform values is controlled by a transform node. So essentially a group is like an empty transform node. So I can hit Control G when nothing is there, and that's what we call a null object. And it's basically just a placement node. And sometimes you do that for various purposes when you need to sort of define a position, but you don't really need an object, and then you can use a null object. And that's essentially what a group is. It's just one of these nodes that controls the placement and also the scale and rotation. But yeah, you can put. Oh, excellent question. So how can we separate it? You can go and click a group and hit Shift G? No, that's not it. You have to select the objects. Oh, Shift P for unparent. That will take them out of the group, and then you can delete the group. Yeah. So contents in a group, maybe you can hit Shift P on the group itself. No, you can't do that. So you got to select all the objects, Shift P for unparent, and now they're out of the group. Let me delete all these other guys. So, right, so there's grouping and there's parenting. For this purpose, I recommend you use groups because it's just more logical, because it's really just a visual or practical purpose of joining objects together without literally kind of making them one mesh. Or, well, it wouldn't be technically one continuous mesh, but it would be one object in Maya. And the way to do that would be to parent. So you see now that's underneath the parent, and the child will follow the parent. So instead of an empty transform node, now this one is controlled by this cube's transform node, and so forth. And I think we can make this one a child of, let's see, you select the child first, and then the parent second. So now we can do interesting things like double transformations, I think. So we can do like, yeah. That's kind of interesting. Like this is getting kind of into rigging and the way you could do like chains and things. Has nothing to do with what we're currently doing, but parenting and making sort of these double transformations is pretty interesting, because now this is a parent of this child, and this child is a parent of this child, and so forth. And so if I select all of them at once, like shift-clicking them, I can rotate, and you'll have this exponential gain, right? Because it's rotating that, and that's rotating that, so you get this double transformation effect. So you can, like a joint chain, you can imagine. Anyways, parenting, you don't need to parent, so I'm going to select all of them, Shift P, so they're unparented, and then select all of them and hit 0, so now they should be back, but they're not. Okay, great. So when you parent, then you group, and things becomes messy. Anyways, Shift P, anyways, go away. All right, so that, was that? Mirroring, yeah, so we'll get into that when we start modeling, like next week. You mean mirroring geometry? Yeah, we do have a mirror function. So if I do that and I delete this and I want to mirror this so to make it a continuous mesh again, I can go to mesh and mirror wherever it is. They keep moving it around. I don't know. Mesh, mirror, there it is. So here, and you can see, okay, we want to mirror with the x-axis. So this is the x, and it's with the x, so it's not minus, but it's plus. And then mirror. So yeah, so we're looking at that next time, because it's very, very useful and necessary, because usually we're modeling symmetrical models, and then you want to spend time on just 1/2 and then mirror it across. Yep. Okay, so Control D, I can copy this and make whatever, so you get the idea, and then, no, let me just, I'll make a door. So obviously you can make groups within groups, that's just, hopefully you'll be a little bit more creative with this, like make some, you can do a lot just using primitives. Yeah, so the goal of the All right. So the goal of the assignment would be to make something that would be really impressive in 1970. Which would amaze people at SIGGRAPH. All right. So there we have the thing, and we could then potentially, well, let me just first of all go like that, delete history and so forth, and then group everything. Now I can also manipulate the pivot point of the group, so I can hold D and V and snap it to the bottom of the group, and then move the group holding X to the grid. Then incidentally, that works kind of nice with scaling, because now the origin of the scaling function is also at the bottom, which is handy. And that could be the origin of the group, and I could freeze transformations on the group node. So if I now move it and move it back, that will be the origin. And then within that group, maybe that little door could be a group. So Control G. And then maybe, we can move that pivot point D, hold V, snap to these verts. Let's see. Or the other one. So obviously now that will rotate like that. All right. So now we have a group within a group. You can do the same for like window frames and go nuts. And there, I could do plane for the ground. I can move the faces, make a little environment. Anyways, yeah. So I think we'll pick this up when we do have the lab session. Like I said, that will be this Monday at 4 o'clock. And the usual lab will be in. I forget because it's a new lab. Well, it's not a new lab. It's not. Yeah, whichever one is on the thing. Let's see. Yeah, so it's not. Yeah, so it's D106. What's that? If the game. Yeah, well, no. There'll be 2 sessions, so there will be after you, essentially. Oh, it's there. Someone put it there. Excellent. Haha. So yeah. So you'll be from 4 till 6:30. Yeah. Yeah, as the other group comes after you guys. We'll do till 9. 10 is a little excessive. But yeah, sometimes this will happen because of all the, construction work and so forth. It's a little bit. This year is a little crazy with the infrastructure. So I hope you're a little bit patient. It's unfortunate, but sometimes we have to go do some night sessions and things to be flexible. You're shocked. Yeah. Yeah. I mean, this will be the case. Sometimes we'll do night sessions. So, okay. Any other questions or concerns about anything? No? So I think we covered a lot of this. We did not cover hypershaded materials and stuff like that, but we'll do that in the lab and do a simple render. You just do a PDF. I don't want any files, so you just literally, let me show you how to do, good question. So just 2 minutes. I can do a print screen. You know how to do a print screen? There's a button on the keyboard. It says PRTSCR. You do a print screen. Well, maybe some people don't know. I don't know. You do a print screen. If you don't know how to do a print screen, you can Google it. Do a print screen. You go into Photoshop. No, a lot of people don't know Photoshop. There's a print screen button on the keyboard. You press it, and then you can paste whatever is on your monitor into Photoshop, which is nice. There's a lady. Did we see any familiar names? Noel, yeah, so he was a part of the Utah team as well. Yeah, there's something called like a snipping tool or something. Yes. What's this? Go away. Oh, okay. New. Oh, it went away. Great. So then we could do that. And then literally you go to the layers, which is currently hidden. There are the layers. You make a new layer, and you hit Control V, and that will just paste the screen you had. Right. So the bare minimum for the delivery would be this. And then ideally you'd show some more angles, and you'd be a little more. Maybe just write like, yeah, so I did this and it was great. And what did you learn? What was difficult? Whatever. It's a little paragraph. For this assignment, you can refer to like, Gibbs reflective cycle if you want, kind of like goes through all the steps of how did I feel? How did all this. Yeah, you can. How did you feel? What happened? What would you do differently? it's not so important, the whole writing bit, but it would be nice if you write a little paragraph and then just whatever. Yeah. And then you upload this as a PDF, which you can export, or no, you can save now. Save as PDF. Can't you? Yeah, this one. Don't save it as a JPEG. Don't save it as a TIFF or a Targa or a PNG. Save it as a PDF, which is the format you will use. And then deliver it to Canvas. Here, assignments, and yeah, whatever. You'll find it and deliver here. By this Tuesday at before midnight. Excellent. Yeah. But we'll basically do that assignment on the Monday, you know. So yeah, you're here, you do it, you upload the PDF. That's fine. So these hand-ins are not meant for me to go in there and give you any sort of feedback. I don't, you know, the feedback you'll be given is informal. It's a formative feedback, and these are not graded. I don't grade them until the end, essentially. So yeah, what I showed you initially, they do influence your grade, but not to such a great degree. So the feedback is more informal. It's in the sessions we have on the lab, you know, so you can, you know, I'll give you some feedback on the work you're doing as you're doing it. Okay, all right. So, all right, have fun at Levanger. There is something happening. There is some sort of event. I don't know. There you go. Should be fun. It's raining, but all right. I don't know. So other things, yeah, no, just welcome. I hope you will enjoy your time here. I do recommend getting into like good habits for this course. It will be very important to actually show up especially for well, for everything, but that you follow along and actually do these little assignments, because they're obviously, it's not like they build on each other. You know, if you don't do this one, you don't know how to navigate in Maya, and you don't know how things work, you can't do the next one. So like the train starts moving now, and you just get on board and then stay on board, you know, and then it'll be fine. But usually, sometimes, you know, for whatever reasons, you know, sometimes students miss a few sessions, and unfortunately, a lot of times in this class, that's problematic, because yeah, the nature of the course. In other courses, it's not a big deal because you can just catch up later. All right, I'll read up on that part later. But here, literally everything depends on the next. So there's this dependency makes it very important to follow along. Yeah. All right, so have fun. Thank you. Thank you.